right, good afternoon, morning, evening, whenever you're watching this to everybody. This is going to be the continuation of April 6th weather class. This is part 4, and we're going to be covering your introduction to climatology and the climate classification system. Now, first thing I want to make sure you guys have done, as per my email, I requested that you guys print out your Test 3 study guide. All right, this is available on pause underneath in the announcement section. It's, the study guides are all down there. So print this out. And the reason for this is, especially in this climate stuff we're going to be talking about, all the key elements, all the lists and details and descriptions and parameters for all the different types of climates we're going to be talking about are all already listed on this study guide. This way I'm not gonna, I'm not gonna be rewriting everything on big sheets of paper to hold up for you guys. You can just follow along with the pre-printed study guide. And of course I'll be talking about it and expanding on the concepts a little bit. And you could either, you take your notes straight on that. But again, I'm not gonna be actually rewriting all these lists that are already on the study guide for you guys. All right, so we've finally moved into the weather section, into the climate section. We've been talking about weather all along, building up, looking at all those elements of weather, looking at all the controls of weather. And now with climate, we're looking at on the big scale. We already know the difference between weather and climate. We know weather is very short term. It's right here, right now, and it's constantly changing. But climate, on the other hand, is the long term. It's the yearly averages of temperature and precipitation. In fact, temp and precip yearly averages are the most basic climate classification that you have. That's all of the systems that are out there are initially going to be based on temperature and precip patterns. All right. A lot of the controls are going, same controls that work over weather elements are going to be working over climate. It's all the same type thing. It's just long term. All right. The climate systems are usually looking at about 30 years worth of data. All right. So again, they are just averages that goes on. Now, today we're going to be looking at the major climate classifications. All right. But we will be breaking those major climates down into even pickier subclimates that fall underneath them. For example, tropical is one of the climate classifications, and eventually we can look at the 3 different subclimates that have little, various nuances to them. And again, that'll be next week. All right, but in addition to temp and precip, what you can look at is any patterns in the temperature or the precipitation. For example, does an area have year-round rain, or does it have a dry summer and only rain in the wintertime? All right. Temperature patterns. Does temperature stay pretty much the same all year round, or do you have a very specific winter versus summer type of temperature pattern? Is your difference between your wintertime low and your summertime high just a little bit? Like say San Francisco, or is it really, really big? Like someplace in Siberia where you've got, over 100-degree temperature range over the course of a year. That can be taken into it. You can even look at the number of days of, say, sunshine versus cloudy skies. Can go in that, all right? And one thing you're going to find, and that the scientists who have done these classifications noticed a long time ago, is that the climate of an area is going to tie in very closely with the plants and the animals that live there. Because obviously weather, all right, temperature, insolation, rainfall is all going to affect the living things that are here on the planet. We know that the biosphere is one of the spheres of the whole Earth system, and it plays a role here as well. Think of a cactus, all right? We know cactuses grow in dry areas, all right? Cactus would not do very well, here in a very, very wet climate. It would just get all soggy and fall apart, all right? So they're adapted to that. Whereas some of the plants that we have here. An oak tree does not, going to thrive very well in a desert climate or something like this. There are some plants that do well. They got to have warm temperatures, and they can't handle freezing temperatures at all, and other plants do. All right, so we're going to be tying in these plants more than anything. Of course, even animals. Animals tend to be a little more adaptive than plants do. But animals basically, you see a polar bear, you're not going to be stuck somewhere down close to the equator in a tropical type of situation unless you're visiting a zoo. All right, so animals to a lesser extent as well. Now, before we actually talk about the major climate classification systems, another word I got to make sure you guys understand is microclimates. Even though we're looking at like the entire southeastern portion of the United States, it's going to be one climate, okay, one little subclimate. But no matter where you are, there are microclimates. There are little areas, and it can be something as little as an aquarium, a 10-gallon aquarium, or a fishbowl for that matter, all right, all the way up to city size. What we mean by a microclimate, it's just where conditions are a little bit more unique and special than the overall climate of an area. So, for example, a fish bowl with a fishy swimming in it. Obviously, that's a very different climate than what is normally found in your room, all right? It's a water climate, so it's very different. But think about a greenhouse. Say at the botanical gardens, which aren't too far from here, you have these greenhouses where it stays warm all year round, and you can grow all these tropical plants even though there may be snow on the ground outside. Inside that building is a microclimate. Inside your house, inside my room here, is a microclimate. If you've got air conditioning and heating going on, so the climate in here is very different than what it is outside the window, you're experiencing a microclimate. You find natural microclimates as well. Of course, imagine that you're in a forest and you look under a fallen log, all right? Lots of different life that is down there, different plants. You're going to find fungus, you're going to find moss. It's an area that stays shaded permanently. It's going to be much cooler because of that. It's going to be a lot more damp because we know that the warmer the temperature is, faster evaporation rates you're going to get. But if it stays cooler than the rest of the forest, evaporation rates are not going to be as high. So that's a microclimate compared to a wide open part of the forest. Here on my house, I've got microclimates all around the outside. The front of my house faces north, which we know never gets any direct sunlight. And so my flower beds that are right up against the house are pretty much in perpetual shade all year round. And so I can only plant ferns and hostas, these shade-loving plants. Now, unfortunately, I've got this one patch, yay big, that's a little further out, and it gets about 4 hours of sunlight a day, which is actually too much for the ferns and the hostas, because I've tried and they get burnt, they get the holes in them and stuff like this. They do not survive. They don't like it. They burn up. But at the same time, it's not really near sunny enough for the sun-loving plants like the marigolds and most of your flowers and stuff like this. I've tried to plant those there as well, and they also don't make it because they don't get enough sun. It's two. In fact, about the only thing I found that works well in that little patch is begonias. Begonias don't seem to give a hoot if it's sunny, shady, somewhere in between. So I highly recommend begonias if you're not sure about what your area is like. All right, now further out in my yard, it is full sun once you get further out there, and so I can plant very different plants. I got some daily lilies and stuff like this that are out there. So again, all surrounding different microclimates, all right? The south-facing backyard would be sunny, you'd think, yes, except I've got a big, giant pecan tree back there that makes the whole backyard shady as well, except in the wintertime. When the leaves are down, the sun does shine back there, but of course I'm not really growing any flowers in the dead of winter, so oh well. But again, constantly changing microclimates. There is one type of microclimate I think I mentioned before. It's called an urban heat island. It's in reference to cities. Take Memphis, for example. In the city proper, we have lots of asphalt. We have lots of buildings. We have lots of cars. We have lots of people. We have lots of air conditioning units, all producing heat. It has different albedo rates than the surrounding countryside might have. And you find this, you have these, again, the reason they're called an urban heat island is that the temperatures around in the cities can be anywhere from 3 to 15 degrees hotter than the surrounding countryside. So if you get the temperature here in Memphis versus what it is out, once you get out to Tipton or Crittenden or Lafayette counties or something like this, where they just have some small towns and it's mostly rural open areas, especially, both in the wintertime and in the summertime, it's generally several degrees hotter here in the Memphis area than it gets out there. A big city, say like New York or Atlanta, again, they can be easily 15 degrees hotter. And they even affects the little weather patterns around that. So all of these, both Atlanta and Memphis and Nashville, for example, we're all in the same climate classification, okay, as the rest of Tennessee is. But those locations, those cities, those urban heat islands are going to have slightly, different temperatures. They're a microclimate as well. Even though it's a big microclimate, it's still small compared to the entire southeast region of the United States. So keep in mind that you've always got microclimates. You may be saying, hey, this plant's not supposed to live here. I've got a cactus growing in my backyard. Well, you got a microclimate going on. It's an area that might be higher up, might be better drainage. You might have slightly different soil because somebody trucked in a bunch of sand one time or sand left over from a construction site or something like that, and it turns out, it does work for a cactus, whereas normally most areas do not. Okay, so keep in mind for those. Now, as we start getting into climate classifications, and in fact, you use your textbook, whatever textbook you are using as a resource, even if you're just using Google and Wikipedia as resources, you are going to want to take a look and be able to pull up the full climate map that has here. Okay, this is the one that's in the textbook that we recommend. But again, it's any physical geography textbook is going to have a climate map in there somewhere, okay, showing this. All right, we're going to be talking about these in a minute, but like you saw in this one, just looking at it, you see there's different colors. Those are different climates. The boundaries between different climates are never going to be razor sharp like they are in these drawings. All right, the boundaries between one climate and another are always going to be really wide transition zones. For example, going from the normally, wet, muggy forests that you might find out in Arkansas to when you start going into Texas from there and you go into an arid climate that is just wide, open grasslands. All right, it's not going to be a case of all of a sudden tree, and then you take one step and there's no more trees to be seen. That transition between the more forested and wetter climate to the drier, only grasslands and no trees can cover 50 or 100 miles. It's just a case of, the trees start to thin out just, a little bit over time, have more open meadowy spaces in between them, and then eventually it's just some scattered trees, and then you finally blend in to the grassland, drier lands as well. So keep that in mind as well. So we'll be talking about borders and latitudes that might be borders, but they are very fuzzy borders, okay? So don't worry about being super strict to one particular latitude, all right? Speaking of latitudes, most of the climate classifications, all right, are going to be based on the latitudes. This is just kind of common sense. This is stuff you guys already know already. All right. We know the tropics, okay? Between the Tropic of Cancer and Capricorn here, 23.5 degrees north and south, the whole area known as the tropics. Guess what? Those are tropical climates, all right? And no surprise, those are going to be the warm climates where it stays warm all year round, all right? You get up into the mid-latitudes, all right? So here's like where the U.S. is. We're up here in the mid-latitudes, both in the northern hemisphere and down here in the southern hemisphere, all right? But we're going to find these are the temperate climates, all right? These are going to be the climates that aren't too hot, aren't too cold, and these are also going to be climates that are going to experience seasons. We're going to actually have winter temperatures that are colder and summer temperatures that are warmer, all right? So as they work their way up. And then, of course, at the top, you're going to have the colder polar climates as you get closer to the poles. Again, be it South Pole or North Pole up here, all right? And then you get those that are cold all the time, all right? So makes pretty sense. So again, with a couple of exceptions, which I will mention here in just a little bit, all the climates are going to be based on latitudes. And again, they're not razor sharp, all right? For example, the tropical climates can actually be found sometimes blending up to 30 degrees north or 30 degrees south as opposed to actually 23.5. Don't freak if you're like, this looks like a tropical climate, but it's at, 29 degrees north and that's not in the tropics. It's okay, all right? It's okay. So you already know that. This is, like I said, it's just common sense. If you see a place that only has cold temperatures, then it's pretty good guess it's going to be a polar climate, all right? It's going to be up here somewhere and things like this, all right? So, again, having a globe, having a world map handy as you study these climates and look at them will help, because I'm going to be giving you lots of locations as examples of where these types of climates can be found. And if you're not familiar with the countries and major cities around the world and stuff, have a map, have a world map, have a globe, if you happen to have one, kind of handy so you can look where places are, okay? So, now there are many different climate classification systems that are out there, all right? Again, all of them initially are based on temperature and precip averages over about 30 years or so, but they have their own little tweaks, and usually when it comes down to figure out different subclimates and stuff like this and definitions. The one that we're going to be using in class, all right, is the Köppen. It's like modified or revised climate classification system. Vladimir Köppen, he first devised this system back in 1900, but he continued to revise it all the way up until his death in the 1940s or something like this. All right, so that's why it's his, but it's gone through several modifications, and probably other folks have modified it a little bit over the past 80 years. All right, but it's the Köppen. All right, so FYI, it is correctly spelled with whatever you call the little dotties. This whatever letter this is with the 2 dots above the O on your study guide, on your tests. I will not be having those because I don't have a keystroke that makes these little symbols. So, if you just see K-O-P-P-E-N, it's not a misspelling, it's the best I can do. Okay, so we have that. All right. So, Köppen, like everybody else, Mr. Blatt, he based his on temperature and precip. All right, and then he used vegetation lines to make his boundaries between one climate and the next, all right? Because he was like, those plants are very dependent upon the climate for their growth, and so where one quits growing and another starts is going to be a very good indicator that there is some kind of difference going on, okay? So what we're going to do next is I'm going to show you just the major climate classification systems that we have. Again, you're on your study guide. listed right here. All right. You will see that I've got letter symbols out to the sides of these. When Mr. Keppen did his classification system, well, first off, he is German-Russian descent, but lived in Germany. And a lot of his symbols basically are tied in with German words for, like dry and wet, which don't make any sense to us. I'm not going to be using the letter system that, at all. You're not going to have to, don't worry about memorizing the symbols or anything like this. But be aware that on all the weather maps, or excuse me, all the climate maps that you look at, they're going to be using the little, 2 or 3 letter symbols instead of writing out the entire climate. Of course, it saves time. There will be a key on all of these that will show you. But sometimes, especially with these major climate classification systems, since it just runs, A through E, which is easy to remember, it helps, kind of organize your brain, might help you remember it. I will often throw that word, throw the ABC down, but I will always be writing out the main name of the climates that you have here. Okay, it's just another tool to help you learn and help you remember that goes on. Okay, so all right, the first ones on the list are the A climates, which are the tropical climates, which again, these you might want to, you can follow along in on your, trying to get it here so it's not so glary, on your maps. All right, having a hard time seeing and showing at the same time. But the tropicals are going to occur, for the most part, within the tropics. And these are going to be based on the fact that they stay warm all year round, again, on average, on a monthly average. Okay, so pretty wide band there with the equator right in the middle. The coldest average monthly temperature in a tropical climate is not going to be below 64.4 degrees Fahrenheit. All right, so that's not saying it doesn't ever get below 64 degrees. That means that on a monthly average, you don't have it dropping below 64. Remember, freaky weather events happen. You get extremes. You might get freezing temps for one night, out of a whole year for 20 minutes. That's not going to say, oh, well, no, we're no longer a tropical climate, because freaky things happen. There might have been a volcano eruption. This has happened before, where there was so much ash and smoke that got up into the air. It made clouds for over a year, and basically it was a year without a summer. So there might have gotten some very cold temps, even in the tropics during that time. This was back in the mid-1800s. It was called the year without a summer, because even up over in Europe, they didn't get their warm summer temps. In fact, even in like June and July, some of the rivers were freezing at night because the temperatures got down, to below freezing, even in the summertime. But it was because of these thick clouds, and also, believe it or not, sulfuric acid that was high up in the atmosphere. This was all the result of this volcanic eruption, and it reflected a lot of the sunlight out, so not near as much insulation made it in down to the Earth's surface, and it was a very cool year. That didn't change the overall climate of Europe, just that 1 year's event. You can have 1 or 2 years, all right? You would never say that Memphis is a dry climate, obviously, especially considering how much rain we've been having lately. But about 20 years ago, I guess it was, 25 years ago, we had a good 18-month drought. And I know it was one summer we didn't get any rain, not enough of significance. Maybe a couple of little afternoon thunder showers that, did just a trace of precipitation one place. But this was a year when I was at Teofilo State Park with my then boyfriend, who was doing turtle research because is a herpetologist. And the big lakes that are down there had dried up completely. And there was one area that the fish, it was probably an area not even as big as this room here, that was only the deepest spot, and it was literally wall-to-wall fish. It was just packed in there because the rest of the just completely dried up. It's kind of freaky, okay? But that didn't change our climate. It was just a freaky event. Some other years will be way above our average rainfall. That doesn't change things as well. The weather extremes that do happen tend to average out. They cancel each other out, so you're left, again, with just whatever the average type of thing is. So keep that in mind whenever we're talking about climates, all right? A one-time freaky event that lasts 20 minutes, 1 day, 1 year, or even 2 years doesn't change a climate, all right? It's just kind of factored in. All right, so tropical climates, all right, that occur in the tropics. And again, the key, they're easy to tell because, again, they're average monthlies temperatures. The coldest one is going to be no colder than 64.4 degrees. All right. Now, the next on the list are the B climates, which are the arid climates. Now, the arid, this is going to include both true deserts, what you think of as deserts, and also something called steppe, which is grasslands. I'll explain these later. These are our dry climates. Now, these are a little bit different when it comes to classifying and figuring out what it is, because arid climates are based on precipitation amounts only, and that is it, okay? Temperature is irrelevant. There are, of course, usually you think of desert, you think hot, and there are some deserts where it gets very, very hot, but there are also deserts where it gets very, very cold. There are deserts in high latitudes, all right? I'm going to look over here in Mongolia, which is up, I don't have my glasses on, so I can't read it, like 45 degrees north or above, way up here, all right, above China is the Gobi Desert. And I mean, it's cold there all the time. It doesn't get terribly hot. Even in the summertime, hot might be 60 degrees, all right? And then, in the wintertime, they might, even get a little spattering of snow, little itty-bitty belts, but it's still a very small, dry climate. I will go over how we determine if an area is truly dry or not next week, all right? So, but with the arid climates, there are multiple reasons that an area can be dry. So you will find arid climates scattered all over the globe, okay? They are not bound by the latitudinal rules at all, okay? So we'll talk about those again in detail next week. Now, the sea climates are the mesothermal. And if you'll recall, the word meso means the middle temperatures, all right? So these aren't too hot, they aren't too cold. We here in Memphis, in the Mid-South, we're a mesothermal climate, all right? We're in the mid-latitudes, all right? And you can look it up on your climate map for the ones that are mesothermal. On the one that I'm showing here, it's kind of, the colors are going to be hard for you guys to see on the line here, all right? So you're just going to have to look yourself, because you can read them just as easily as I can, whichever climate map that you have, all right? But these are the first of the temperate climates. Again, not too hot, not too cold. The mesothermal are going to be the milder of the temperate climates. Again, it's us. We have hot summers and we have very mild winters. Snow is not, a never type of deal, but it's also a pretty rare deal. You know what it's like when we get snow here. We don't know what to do with it. And if we do get it, it's usually just a little spattering. I can't even remember how long it's been since we, got a decent amount of snow where you were actually able to make a snowman that was like a decent sized snowman and not some kind of little mini thing that you were just scraping, you know, that scattering, that dusting of snow. Shoot, my son had to be, God, this was 6 years ago? I honestly don't remember. It's been so long since we've had a really, you know, a good snow where you could actually bring out a sled. I got a sled that I've had since I was a kid that's still in the our garage here, and it looks pretty much brand spanking new, except for the bottom runners that always got scraped up going down the driveway because it, you know, the snow never lasted. So anyway, but those are mesothermal. Usually kind of the lower middle latitudes, but we'll see exceptions to the rules to that as it goes on. The other temperate climates that are still in the mid-latitudes, these are usually more upper mid-latitudes though. These are the microthermal. So micro means smaller. So here they also have hot summers, but they tend to have much colder and also snow-inclined winters. People that live in microthermal climates will have snow chains on their tires. They know how to drive in the snow, and you know, they've got all the sleds and everything like this because you know it's going to snow. It may not be snowy all winter long, but you know you're going to get a significant amount of snow. So it can be anything from Chicago and New York to even more extreme areas like you have up in Maine or in the middle part of Canada and Siberia and places like this. Okay, so mesothermal, which are the C climates, and microthermal, which are the D climates, those are your temperate mid-latitude brains, the ones that actually have seasons. Some are more defined than others, but you've got your, you know, your changing winter, summer, spring, fall type situation going on. Now, E are the polar climates, all right, that are going to occur up in the polar areas, up in the Arctic Circle or the Antarctic Circle, all right, and these are the ones that are going to be cold all the time. I forgot to go over the temperature characteristics of all these climates, so let me back up a minute. Okay, to revisit, we've got tropical A's, which the coldest month is greater than 64.4 degrees Fahrenheit, all right? Arid, we said, is defined only by precipitation amounts. Temperature is irrelevant, okay? Doesn't matter at all for arids. Mesothermal, all right, the coldest month is going to be less than 64.4, obviously, and greater than 32, greater than freezing, okay? And the warmest month has got to be at least greater than 50, all right? So we're saying, yeah, you get a pretty warm summer that goes on, but the winter is not averaging below freezing on a regular basis. As you well know, it does get below freezing here on some nights in some months, all right? But we're talking about an average temp for the entire month. It's, you know, rarely, if ever, has it been below freezing. One time, again, this was 25 years ago, something like this, we had a freaky December where it did not get above freezing, hardly at all, the entire month of December. This was when I was in this old duplex that only had a floor furnace that was in the very front of the building. My back bedroom, I actually, you know, had ice. A good friend of mine lived in Midtown in an old Victorian style house. Her entire toilet froze up for about 2 weeks. It was frozen solid. They could not use it because there wasn't any, you know, there was no heat vents or anything in these old houses and these old bathrooms. And yeah, it was a cold. I found the joys of long underwear during that time. All right, but again, it was a freaky event, one-time event. This will never happen again, not in my lifetime that I'm aware of. Anyway, okay. So that's the mesothermal. So again, mid-range temperatures. We're not as hot all year round as the tropicals, but we're not that cold either. The microthermal, the coldest is below 32. All right, so they're going to have at least 1 month that averages below 32 degrees. And their warmest month is going to be above 50. So you still have warm summers, but you have much colder winters. Okay. The polar climates, those E-climates, there it's pretty easy. The warmest month is below 50 degrees. All right. And it can be as cold as it wants, but the warmest month is below 50 degrees or less than 50 degrees Fahrenheit. Okay, so again, they all make sense. It all makes sense. Now, the last one that's on your list is the H climate, which is highland. These are kind of little outliers. This is going to be referring to areas where you have really tall mountain ranges. Okay, so for example, here in North America, it's going to be referencing the Rocky Mountains, possibly some of the Sierras, the Cascades, and the mountain ranges, the coastal mountain ranges that you have all the way up through Canada and into Alaska. All right, that's our Smoky Mountains over here in East Tennessee aren't tall enough to be called a highland climate. They're not high enough. That goes on. In South America, you're going to have the Andes, which are an extremely high mountain range. Some of these go up 3 miles up, 2-3 miles high, and maybe even higher than that. All right, running along the whole west coast of South America. All right, so that's a good example. In Europe, you have the Alps. All right, one of these mountain ranges that runs east-west and keeps the cold air masses from meeting up with the warmer air masses. Yeah, so the Alps all through this area in northern Italy and Switzerland and Eastern Europe and these areas. All right, so that's one of the locations. We've got, where am I trying to think? There are down in New Zealand. I do not know the names of their mountains, but they have some really high mountains down here in New Zealand as well. So we'll see those there. And then all through kind of Asia, of course, the tallest mountain range in the world are the Himalayan ranges right here above India and in Nepal and China, the whole Himalayan plateau, which is very high. There's a lot of other extremely high mountain ranges over in this area, everything from Pakistan and Afghanistan and all through Kazakhstan, and many of these areas over here have a lot of very high mountain ranges. And as we know, that the higher up in the atmosphere you go, the temperature gets colder. And so what we see in highland climates is basically examples of all the climate temperatures, but in one spot. Okay, so it's hot down at the base of the mountain, and then you've got polar climate at the top of the mountain, even though you might be literally sitting on the equator. And there's true, there are mountains, there's some volcanoes in Africa that are right on the equator, and they have a permanent ice cap at the top. All right, so instead of trying to classify all those little itty-bitty climates, we just lump it all together and call it a highland climate and say it's got a whole mixed bag due to elevation. Okay, so we'll talk a little bit about more of those in detail next week as well. All right, so that is all the material we're going to cover for our intro to climate classification. So you guys can get very familiar with the major climate classifications. Now, your lab for this class, which is due Sunday night, yes, all right, you should already have this lab sheet, which I emailed you, all right. And the way that you work, it's actually very simple, okay? What we have here, instructions are all written out on here, but I'm going to go over it with you again as well. All right, up here at the top, you've got the months, January through December. Now, this column right here on the very, very end, that's your yearly averages, and totals. So we're looking at temperature and precip. That's what the TP stands for, all right? Temperature is in Fahrenheit, and that's going to be the average of each month, okay? It's just the average of the month. It's not the highest of the month or the lowest temp of the month. It's the average of the month, all right? So that's going to be across for each month, all right? And then the yearly, that's your yearly average temperature, okay? The precipitation amount is the average amount for each month, all right? You know, and that's not, I mean, that's, you know, for, again, on about a 30-year basis, okay? So normally, like the first one is Peru, and they get 10.2 inches of rain on average every January, all right? And then at the yearly, that tells you, again, the total amount of rain they normally get, their normal average yearly rainfall. You're not actually going to be using the yearly totals for this exercise at all. That's why I highlighted it, because it's real easy just, you know, as you're glancing across these and trying to read them, you forget that the year is not part of what you're worried about, okay? But that's why I highlighted it different colors, all right? But again, all you're gonna do, of course, you've got on, you know, down here at the bottom, I rewrote out what makes the parameters to make it a tropical climate, what makes it to be a mesothermal, a microthermal, and a polar climate as well. And for these, you're just going to be looking at the temperature, okay? I've already marked the ones that are arid. As like I said, I will explain later, the formula to figure out if an area is arid or not is a little more complicated. I'll explain how that goes on, but for this stage of the game, you don't have to worry about it. I've already marked these locations, okay? So you're gonna look at the temperatures, all right, across the year for each location. You're gonna follow the guidelines down here to figure out, is it tropical? If it's tropical, you write tropical out beside it. Is it mesothermal? You'll write mesothermal. Does it fit the temperature parameters for microthermal? You'll write that on there as well, all right? Now, to help you learn, to help stress this information, to help have it make sense so it starts to click, I highly recommend that you look up where these countries, some of them are cities, you know, I give the country as well, because some big countries have multiple climates. That's why the city's there. People like, you know, there's multiple different climate classifications in the United States. So just saying the United States doesn't mean anything. All right. Some of them are smaller countries and it's all pretty much the same climate. But if you don't know where they are, or even if you do, again, look at it on the map. See where the, you know, what latitude it is. How is it in, you know, close to the coast? Is it in the middle of the continent? Because that's going to factor in later on when we get into the more specific subclimates, the little more pickier classifications that we have. So, you know, please do that. That's for you. I know where these places are. You may not. So get familiar with it. It's a good way to learn the globe. All right. But that's all you're going to do. You're going to write down which of the major climate classification it is on this sheet. And then once you do that, go to pause, go to the, you know, assignments or the quiz, whatever it's on there. This one's lab 21. And I'll have the same places all listed in the exact same order, and you'll just click on the correct climate classification that you came up with. All right. It's actually kind of fun to this. It doesn't take very long at all. One thing I do recommend that you do when you're working this is get a spare sheet of paper to highlight the one that you are doing, because it's real easy for your eyes to start, you know, to drop down a row or something like that, and, you know, trying to keep up with it. So if you'll keep a sheet of paper underneath the one that you're working, that will very, you know, help you guide your eyes and help you from getting confused and things like this. All right. So next week like I said, we will be looking at the subclimates that fall underneath all these major climates. And of course, we'll talk about that next week. This is enough for now, so this will be it. Guys, again, stay safe, stay healthy, stay at home, and see you next time. Thanks, bye.